Hi friends, in this video we are going to discuss about change the order of integration and here how to change the order of integration and what is the need of that to change the order of integration. So here I will quickly explain. For example, if you have double integral, let's say here 0 to a and let's say 0 to x, and here if you have any function f of x comma y, whenever the inner limits of your integral, it depends on x variable. So here this is the inner limit of this integration. So here inner limit in terms of x variable. At that time, the correct order of your integration, first integrate with respect to dy and then dx. And here inner limit in terms of x variable. So first integrate with respect to y and then x with respect to this limit. So here, for example, in the same way, let's say 0 to a and here let's say 0 to y, and here I am taking the function f of x comma y. Here the inner limits of my integrations in terms of y variable. So first integrate with respect to dx and then dy. So here shortcut, whenever inner limit in terms of x variable, integrate first with respect to y and then x. Whenever inner limit in terms of y variable, at that time first integrate with respect to x and then y. So here this is the trick. Now here sometimes, so this is your function, let's say anything. So here 0 to x, 0 to a f of x comma y dy dx. Sometimes integration of this function with respect to y is difficult. So to make it easy, we need to change this dy by dx by dx by dy. So here while changing the order of integration, so here this is integration of this function with respect to y, so corresponding to this limit. So here I am changing the order of integration from dy by dx to dx by dy. At that time I need to change limit also. So here how to change? So here why? Here I will explain with the help of this example why we need the change of order from dy dx to dx dy, and while changing the order dy dx to dx dy, how to change this limit? Here I will explain with the help of this example. So here first I will discuss example. So here, for example, if you have one function f of x comma y equal to e to the power y square dy dx. Here first integration 0 to 1 constant limit, second integration x to 1. So here inner limit of your this integration in terms of x variable. So first integrate with respect to y and then dx. But now you just observe one thing. So this is the function e to the power y square. So has this e to the power y square has no any fundamental formula to evaluate this integral. So either you can multiply one and use the by parts formula. Again you have to use the substitution method. This is possible, but here somewhat lengthy. So here in place of this dy dx, now here I will use the order dx dy. Here I want to change this order from dy dx to dx dy. In the same way I want to change the order, so I need to change the order. So here this is integration with respect to y, so corresponding to this limit. Now I want to change from dy dx to dx dy. In the same way I want to change this order also. Now just first I will draw the region of this integration with respect to this limit. So here integration x to 1. So here second limits in terms of x variable from x to 1. So here that must be the value of y. So here I am taking this is this is here corresponding to this x is less than equal to y, which is less than or equal to 1. So here x to 1, that must be the value of y, that is not again the value of x. So here that's why here I am taking y belongs to this closed interval x to 1. Here if this is the value of y, that must be the value of x. Therefore 0 is less than or equal to x, which is less than or equal to 1. Now here with the help of this two closed interval, I will draw the region of my integration of the function e to the power y square. Now here corresponding to this, here integrate first with respect to y. So here I will use, so this is corresponding to the vertical strip method. So here 0 is less than or equal to x, which is less than or equal to 1. So here at the right end of this closed interval, so here value of x equal to 1, value of x equal to 0, and the right end of this interval, so here x equal to 1. So here x equal to 0 and x equal to 1, and all the value of x belongs to this closed interval 0 to 1. So here the x belongs to the closed interval 0 to 1. X takes all the value from x equal to 0 to x equal to 1. So here this is my origin. So here this is x axis, here this is y axis, here this is my origin, and x equal to 0 means complete y axis. Here x equal to 0 means complete y axis, and x equal to 1 means here I will take this line just for the sake of understanding. Let's say this is my line x equal to 1. Now the value of x satisfy all the conditions. So here 0, here 0 is less than or equal to x, which is less than or equal to, here I will draw this, here let's say this is the line x equal to 1. Now here now come to this interval, y belongs to the closed interval x to 1. So here at this end of this closed interval x equal to y. So here and at the right corner, at the right end of this closed interval must be y equal to some 1 times 1. So here x is less than or equal to y, which is less than or equal to 1, means at the left end of this closed interval. So here x equal to y, and the right end of this closed interval 1 times y equal to 1. So here I will draw the line once y equal to 1. Let's say this is the line y equal to 1, and here y equal to x, line passing through the origin. Let's say this is my line passing through origin. Now just observe one thing. 0 is less than or equal to x is less than or equal to 1. So here x belongs to this 0 to 1. So here x belongs to here. But just observe one thing. Here x is less than or equal to y, which is less than or equal to 1. Here the value of y here above this x. So here if this is the y equal to, here if this is the y equal to x equal to y or y equal to x, here y is greater than or equal to x. So here if this is the y equal to x, so here this is my region. So here this is my region. Now this is my region. I want to cover this region with the help of to find the total accumulation of this function over this region. Now here in the first time they have given integrate first with respect to dy and then dx. So corresponding to this limit. So here I am using the vertical strip method, which is parallel to y axis. So here my region is this. So here I don't want this. Here I am drawing this line just to find the point of intersection of y equal to 1 and x equal to 1. So here they intersect at the point 1 comma 1. Here I will give this name P. This is O and this is Q. So here the coordinates of Q are 0 comma 1. The coordinates of Q are 0 comma 1, P 1 comma 1 and O 0 comma 0. Now this is the line y equal to x, so you can say x equal to y equal to x, and here this is the vertical strip which is parallel to y axis. Now just observe one thing. Here this is the integration with respect to dy and then dx. That's why here I am using the vertical strip which is parallel to y axis. Now I want to first in here now the limits of x. So here corresponding to this limits of x. So here limit of x equal to limits of x are here the value of x height along the y axis x equal to here x equal to 0 along the y axis to 1. So here x equal to 0 to x equal to 1. This is the limits of x, and limits of y. So here limit of y. Limits of y, here the value of y equal to x. My strip start at y equal to x line and terminate at this line y equal to 1. So here y equal to x to y equal to 1. So this is the limit corresponding to this integration with order dy by dx. Now with this same region I want to change the order from dy dx to dx dy. So here I want to change the order. So here just I will draw the horizontal strip which is parallel to y axis. Here the region is same. Here region is same. Let's say P with coordinate 1 comma 1, and this is origin with coordinate 0 comma 0, and this is Q with coordinate 0 comma 1. So this is my line y equal to 1. This is my line y equal to x, and this is the line where x equal to 0. So here my region is this one. Now I want to cover this same region with the help of horizontal strip, A B, which is parallel to x axis. So here this strip AB which is parallel to y axis. Now here I want to write, here I want to make this order dy by dx to dx dy. So here if I want to make the order dy by dx to dx by dy, then I want to here I draw the strip AB which is parallel to x-axis. So here I am drawing the strip AB which is parallel to x-axis. Now tell me the limits of x. So here the height of x along the x-axis. So here x equal to 0. Here my strip start at the y-axis and terminate on this line x equal to y equal to x. And along the y-axis the value of x equal to 0. Here x equal to 0 to x equal to y. So the value of x at this line. So here if y equal to x, so then x equal to y. Therefore limits of x, limit of x and limit of y. Now limits of x start from x equal to 0 to x equal to 1. So here x equal to 0 to x equal to y, and limits of y. Here my strip move vertical. So here vertical direction to cover this whole region. So here y equal to 0 to y equal to 1. So here y equal to 0 to y equal to 1. Therefore after changing the order with respect to this limit, so here in the this is first, this is second. So here after changing this order, let's say here with respect to first, here x equal to 0 to 1, here y equal to x to 1, this is e to the power y square, here dy and dx. So which is with respect to first. Here I want to write with respect to 2. Here now here the limits of, now here first integrate with respect to dy and then dx, because here now I want to make dy dx, in place of dy dx I want to make this is dx and then dy. Here if inner limit in terms of, here we are integrating first with respect to dx. So here I will write the limits of x. So limits of x are x equal to 0 to, here x equal to 0 to x equal to y. So here x equal to 0. So here this is x equal to 0 to x equal to y, and limits of y. So here y equal to 0 to y equal to 1. So here this is e to the power y square dx dy. So this is the way to change the order from dy by dx with respect to this limit to dx by dy with respect to this limit. Here why we are changing this limit, and why we are changing this order from dy by dx to dx by dy. Here I will explain with the help of same example. So here now in the starting, so here this is the order of integration dy by dx. Now there is no fundamental formula to evaluate this integral. So we have to multiply by 1. Again we have to use the by parts formula. But now here in this, after changing this order from dy dx to dx dy, just observe one thing. So here integration 0 to 1, 0 to y e to the power y square dx dy. Now here this time I want to integrate with respect to first dx and then dy. While integrating this function with respect to dx, so here y variable is a constant. So I will treat this function as a constant. So here this is equal to, here 0 to 1. So here constant of integration is e to the power y square. Here integration of this function constant with respect to x, this is y. Here limits are 0 to y. So here limits are 0 to y. So here this is my this is x. So here e to the power y square is constant, and integration of 1 with respect to x is x. So here limits are 0 to y, and the last is with respect to dy. So here which is equal to, so here I will write this same 0 to 1. So here e to the power y square. Now here upper limit minus lower limit. Here y minus 0. This is dy, which is equal to 0 to 1 e to the power y square y. This is dy. Now here either you can use the substitution method, or here I am using this method. So here you know integration of e to the power f of y into f dash of y dy, which is equal to f e to the power f of y. So here this is the formula. Integration of e to the power f of y into f dash of y dy, which is equal to e to the power f of y. Here e to the power f of y is y square. Here I will multiply here e to the power y square. Here derivative of f of y, derivative of y square is 2y. Here I am multiplying 2 and divide by 2. So here this is my f dash. So this is my e to the power f of y into 2y is my f dash of y. So here I will take this 2 outside. So which is equal to 1 by 2 times. So here again I will write 0 to 1 e to the power y square 2y, this is dy. So here this is e to the power f of y into f dash of y dy. So here which is equal to e to the power f of y. So here which is equal to 1 by 2 times e to the power f of y, that is y square, and limits are here 0 to 1. So which is equal to 1 by 2 times e to the power 1 minus e to the power 0, which is equal to 1 by 2 times e minus e to the power 0 is 1, which is equal to e minus 1 by 2. This is the integration. So here, but in the starting, if you calculate, if you find the integration of this function first with respect to dy and then dx, which is somewhat lengthy, in place of that, change the order from dy by dx to dx dy. So change the order from dy by dx to dx dy, and also change the limit. So with respect to this region, so here you will get the answer in very few steps. So that's why we are changing the order of integration from dy by dx to dx dy, or vice versa, dx dy to dy to simplify, to get the answer in few steps, or for easy evaluation purpose. Now here in example number 6 they have given the information. So again I will write this same example over here. So example number 6, integration from 0 to 8 limits, and second y minus 8 by 4 to y by 4. This is the function f of x comma y. Here in the question they have given order is this is dx and dy. So this is the way. So here just observe one thing, the limits of your second integration in terms of y variable, that must be the value of x, that is not the value of y again. So here this means that my x belongs to this y minus 8 by 4, which is less than or equal to x is less than or equal to y by 4. So that is the value of x belongs to this closed interval y minus 8 by 4 to y by 4. And if this is the value of x, that must be the value of y. So here I will write this is y minus 8 by 4, which is less than or equal to x, which is less than or equal to y divided by 4. If this is the value of x, so that must be the value of y. Here 0 is less than or equal to y, which is less than or equal to 8. So here the closed interval from 0 to 8, take all the value from closed interval 0 to 8, and x takes all the value from the closed interval y minus 8 by 4 to y by 4. So this is the meaning of this closed interval 0 to 8 and y minus 8 by 4 to y by 4. So now here this is the closed interval. So here at the left end of your closed interval 1 times y must be 0, and at the right end of this closed interval 1 times y must be equal to 8. In the same way here in this closed interval, here x must be here y minus 8 by 4, which is equal to x, and x must be equal to y divided by 4 at the right end. So here this is at the right end and this is at the left end. So here according to this y equal to 0 means complete x axis, y equal to 8 means the line which is parallel to x axis above the x axis, which is so here I will draw the region. Just observe one thing. So here corresponding to this, so here y equal to 0. So here y equal to 0 means, so this is the x, y equal to 0 means this is the complete x axis. So here along the complete x axis the value of y equal to 0, and y equal to 8. So here somewhere here I will take y equal to 8. So here if this is the origin, so here 1 2 3, here in the same way here I am taking y equal to 8. So for the sake of understanding, so here this is my line y equal to 8. Now here y minus 8 by 4, which is equal to x. So I will write here y minus 8, which is equal to 4 times x. So here 4x minus y, which is equal to 8. So here 4x minus y. So here y minus 8 equal to 4x. So here y minus 4x, which is equal to 8. So here again y minus 4x, which is equal to 8. Here I will take 4x left hand side and 8 right hand side. So here I will write minus 4x plus y, which is equal to 8. So here I will divide this 8. So here minus 4x by 8 divided by y by 8, which is equal to 1. Now this is same as, so here minus x by 2 plus y by 8, which is equal to 1. So here this is my line. So here this is my line y minus 4x equal to 8. So here you can say this Yes, minus 4x plus y equal to 8. Let's say this is my line. Here I will consider this is my line, and this line intersect at x-axis at minus 2. So here I will write this minus 2 here, and this line intersect at y-axis at 8. So here this says that this line L intersect at x-axis at minus 2 and this line intersect at y-axis at 8. So here this is the line y equal to 8. That must be here. I will take the coordinates of this here. Let's say A with coordinate here x coordinate is 0 and y coordinate is 8. Now here if this is 0, let's say this is 1, and let's say here I am taking this is equal to minus 2. For the sake of understanding, let's say here I am taking, let's say this is 1 and here I am taking minus 2 comma 0 y coordinate. So here my line, this line intersect at x-axis at minus 2 and at y-axis at 2. So here I will draw this line. So this is my line. So here I will write this line as, so here minus 4x plus y, which is equal to 8. So this is the equation of line. So here this line minus 4x plus y equal to 8 intersect at x-axis at minus 2 and intersect at y-axis at y-axis at 8. So at 8 means with coordinate 0, 8. Now in the same way here I will solve. So this is the graph. Now here y equal to 0. Here y equal to 0 means complete x-axis and y equal to 8. This is my line y equal to 8. Now here I will solve this and I will draw the remaining region. So here now come to here, x equal to y by 4. X equal to y by 4. So here 4x equal. So 4x equal to, let's say y, or I will write y equal to 4 times x. So here y equal to x, again line passing through origin. So here I will draw, and let's say again line passing through origin. So here this is the line y equal to x and y equal to 4x, just slanted towards the y-axis. Now here this is. Now I want to find. So here I know the point of intersection at this point. I know the point of intersection at this point. I know the point of intersection at this point, but I don't know the point of intersection at this point. First I want to find where this line y equal to 8 and y equal to 4x intersect each other. Now here y equal to 4x and y equal to 8. So here left hand side same, 4x equal to 8, therefore x equal to 2. So here x coordinate is, let's say 2. So here x is 2 and y is 8. So here they intersect. The line y equal to 4x and y equal to 8, they intersect at each other with coordinate 2, 8. Here I will give the name of that coordinate as B with coordinate 2, 8. So here just observe one thing. The value of y. So here the value of y belongs to 0 to 8. So here 0 is less than or equal to y, which is less than or equal to 8. So this is my line y equal to 8, which is parallel to x-axis, and y equal to 0. So here y equal to 8, 0 is the complete x-axis. Along the x-axis, the value of y is 0. So here the value of y belongs to this region. So here complete this region. Now second thing, here the value of x belongs to this here. Here the value of x is bounded by this line and this line. So here y equal to 4x, the value of x is completely belongs to this interval. So here y minus 8 by 4. So this line is bounded by this line and this line. So here my region of my integration is this. Here, so this is my region of integration is here bounded by these two lines, minus 4x plus y equal to 8 and y equal to 4x. So here it is bounded by these two lines and this x-axis and y equal to 8. X-axis means y equal to 0, y equal to 8, and this two lines. So this is my region of my integration complete. So here this rectangle, slanted rectangle. Now here they are saying in the given question, first integrate with respect to dx and then dy. After that I want to change this order from dx dy to dy dx. So here I want to change. But now integrate first with respect to dx means they are using horizontal strip which is parallel to x-axis. Now here I will use this strip AB. So here let's say this is my strip AB which is parallel to x-axis. Now here this is, let's say this is my strip A. Let's say this is my strip C and D. Now my horizontal strip CD start at this line. So here height along the x-axis means height along the x-axis that corresponding to the corresponding to the value of x. So here I want to find the value of x at this point, and I want to find the value of x at this point. Now here, this is my horizontal strip CD. Start at this line minus 4x plus y equal to 8 and terminate on this line y equal to 4x. Now here, so this is the reason. So after that I want to find the limits x and limits y. So here with respect to this, now here and the value of y. So here this is the limits of x. Start from here this line minus 4x plus y equal to 8 to y equal to 4x. Therefore height along the x axis means either in this direction or in this direction, that is the height of x. So here that is the height of x. So along the positive direction or negative direction. So here I want to find. So here minus 4x plus y equal to 8. I want to write the value of x, the general value of x corresponding to which satisfy for all the point along this line. So here minus 4x plus y equal to 8 is same as, so here y minus 8 equal to 4 times x. So here 4x equal to y minus 8, x equal to y minus 8 divided by 4. So here the value of x, y minus 8 by 4 to here y equal to 4x. Y equal to 4x is same as 4x equal to y, therefore x equal to y by 4. So therefore the limits of x, therefore the limits of here, limit of x and limits of y. So here I will write limit here, limit of x. Here x equal to y minus 8 by 4 to x equal to y by 4 corresponding to the this strip CD which is parallel to x axis. In the same way, here my strip movement from starting from this point to this point to cover the whole region of, let's say this is O B A, let's say this is O B, here I will take this is P. So here O B A P. So this is my region. My strip want to cover this whole region O, B, A and P. Now just observe one thing. So here while covering this region, so this is x limit start from y minus 8 by 4 to x equal to y by 4 and limits of y. So here limits of y equal to y equal to. So here at this point y equal to 0 to y equal to, here the value of y at this point y equal to 8. So here this is given in the question. Limits of x, y minus 8 by 4 to y by 4 and limits of y. So here y equal to 0 to y equal to 8. So this is the given. But now in place of that I want to change the order from dx dy to dy dx. So here if the order is dx dy, so here the strip, here I draw the strip CD which is parallel to x axis. But now I want to change the order from dx dy to dy dx. At that time I want to use the vertical strip which is parallel to y axis. Now here how to draw and how to take the limit is the following. Now just observe one thing. So here I want to cover the same region. Here this is corresponding to this. I want to cover the same region but with the help of vertical strip. So here I want to draw the same region, but in place of that here I will explain the same thing over here. So again let's forget. Again I will draw one region. So here, so this is y equal to 8. So this is line y equal to 8 and this is my line y equal to 4x. Here y equal to 4x and this is my line here minus 4x plus y equal to 8 and here this is the coordinates a coordinate with minus 2 comma 0. This is my origin 0 comma 0 and let's say this is b coordinate with 2 comma 8 and let's say here I am taking a with 0 comma 8. Now I want to cover the same region with the help of vertical strip method. Now here let's say this is my strip. Here I will take, let's say this is the strip which is parallel to y axis. Here if I take this strip anything, so here which is parallel to y axis, is it here if I take this strip which is parallel to y axis, here while covering this whole region, so here in the starting, let's say this is the initial terminal of my strip and this is the end terminal of my strip. So here while covering this region, so here one terminal shift from this line x axis, that is y equal to 0 to y equal to 4x. So here with the help of single strip it is not possible to cover the whole region, that is O B A P. So here O A B, let's say this is P. So this is P point with coordinate minus 2 comma 0. So here if I take the strip here, while covering this region from here to here, both the terminal of my strip on the same line here, the above terminal on this line and the below terminal on this line, but while covering this region, here the one terminal shift to this line and the other terminal shift to this line, y equal to 8. So that's why here I will draw the two strips. So here let's say here I will draw one strip which is parallel to y axis. Let's say this is C and D, and here to cover this region, so here to cover this first region and to cover this second region, I will draw another strip. Let's say this is another strip. Let's say this is C dash and D dash to cover my second region. So here to cover my first region, here I am dividing this whole region POBA into two regions, POA and OBA. So here I am dividing my region into two parts. This is my first region and this is my second region. So here in the first region, to cover the first region, here I draw the strip CD which is parallel to y axis, start from x axis and terminate on this line. While covering this region, here I draw the strip C dash D dash which is parallel to y axis, start from the line y equal to 4x and terminate on the line y equal to 8. So here I will write the limits of x and limits of y corresponding to first region and corresponding to second region. After that I will add these two regions to evaluate this integration over the complete region. So here first I will write the limits of x and limits of y in terms of first and second region. Just focus on this first region, that is my region of my integration. The region of my integration is PO. Let's say here PO and A. So this is the region of my integration, triangle POA. In this triangle POA, the strip CD which is parallel to y axis start from x axis and terminate on this line. So here on x axis y equal to 0, and I want to find the value of y at this point. So here on x axis, so y equal to 0, and here I want to find here the value of y, the general value, minus 4x plus y which is equal to 8. Therefore y equal to 8 plus 4x. So this is the value of y. Wait. So here I want to find the value of y. So here minus 4x plus y equal to 8. So here y minus 4x plus y equal to 8, y equal to 8 plus 4x. Here this is the one, and in my region first, here let's say this is my first region. So here I want to find the limits of x and limits of y. So here in my region 1, the strip CD which is parallel to x axis, so which is parallel to y axis, start from x axis and terminate on this line. So here on the x axis the value of y equal to 0, and on this line the value of y equal to, so here 4x plus y minus 4x plus y equal to 8. Therefore y equal to 8 plus 4x, and so this is the value of y. So this is the limits of y. Here y equal to 0 to y equal to 8 plus 4x. Now I want to find the limits of x. So here height along the x axis. So here minus 2 to 0. So here my strip move from at this point to this point. So here at this point value of x is minus 2, and at this point value of x is 0. Therefore the value of x start from minus 2, that is limits of x, minus 2 to x equal to 0. Therefore here I will write the limits of x and limits of y in first region and in second region. Now here in first region, so here limit of x and limit of y. Here in first region limits of x minus 2 to 0. So x equal to minus 2 to x equal to 0, and limits of y. Here y equal to 0 to here. Limits of y start from y equal to 0 to y equal to 4x plus 8. This is the limits of x and y corresponding to the region R, corresponding to the region 1, which is equal to POA. Now I want to find the limits of x and y corresponding to the region 2. So here in region 2, so here R equal to, that is in region 2 is O, let's say B and OB, and let's say here I am taking the OBA. And now tell me the limits of y and limits of x. So here limits of y start from y equal to, so here my strip CD start from this line y equal to 4x and terminate on this line y equal to x. So here y equal to 4x, that is limits of x and limits of y. So here limits of x limit of x and limit of y. So here limits of x and limits of y. So here limits of y. First I will write the limits of y and then limits of x. So just observe one thing. Limits of x start from this point to at this point. So here at this point to this point, which is parallel. So here x equal to 0 to x equal to 2. So here x equal to 0 to x equal to 2. And limits of y equal to 4x to y equal to 8. So here y equal to 4x to y equal to 8. Therefore, so these are the limits corresponding to the second region. These are the limits corresponding to the first region with respect to dx and dy. So here dx dy and this is dx dy corresponding to this. Now here after changing this order, therefore after changing this order, here I will write. So here given order is 0 to 8. Here y minus 8 by 4 to y divided by 4. This is f of x comma y. This is dx and dy. So here I converted this region into two parts with respect to here. This is dx dy with respect to dy and dx. So here this is first region. Here this is first region f of x comma y. This is here dy and then dx plus here I am writing the second region. So here this is my region 1 and this is my region 2. So here f of x comma y. This is dy and then dx. Now here when I am integrating first with respect to dy and then dx. Write the limits of y. Limits of y start from 4x to 8 and sorry. So this is corresponding to the first region. So here I want to write first region. So here in the first region, limits of y 0 to here 0 to 4x plus 8 and limits of x here minus 2 to 0. Now come to the second region. So here these are the limits corresponding to the second region. The limits of y are 4x to 8 and limits of x are 0 to 2. So here this is the order of integration. So here in the starting dx dy, here I am changing this order dx dy to dy dx. So here this is the way to change the order from dx dy to dy dx. So here I am dividing this region. Here I am dividing this region into two parts to cover the whole region with the help of vertical strip. Here with the help of horizontal strip we can cover the region without changing the terminal of your strip C and D. So here while covering this whole region with CD which is parallel to y-axis, here from here to here to cover the complete region, the one terminal of my strip CD is on the fixed line minus 4x plus y equal to 8 and the other terminal of my strip CD is fixed on this line y equal to 4x. But while covering this region with the help of vertical strip, so from here to here, that my strip CD, one terminal on this line, on this x-axis, or we can say y equal to 0, and other terminal at this line, and while covering this region, here my strip CD jump to this line. So here and the other terminal jump to this line in place of this. That's why here I am dividing the whole region into two parts. So here this is my one part and this is my other part. So after that here I am adding these two parts to get the complete region. So here this is the way to change the order of integration from dx dy to dy dx with limit. So here I am changing the limit as well as I am changing the order of integration. In the same way I will explain example number 5 so that you will get one complete idea. So I will explain this profile problem so that we can in exam or anywhere you will get any problem you can solve easily. So but here just try to focus how I am changing the order, and while changing the order from dx dy, how I am changing the limits also with respect to here integration with respect to dx. So limits of y, limits of x, so in terms of y variable. So here integration with respect to y, limits of y in terms of x variable. So here this is the way. Now here I will solve example number 5. The order of integration. Now here in example 5 they have given the order. So first read the example number 5. So here limits are limits of the first integral 0 to 1 and limits of the second integral x to root x. This is f of x comma y here this is dy and then dx. Now just observe one thing, limits of my second integral in terms of x variable. So first integrate with respect to y and then x with respect to this limit and this order dy dx. So here with respect to this order dy dx, these are the limits. Now here first I will draw the region. So after that I will change this dy dx to dx and then dy. So here this is the given order, this is the correct order. Here I want to change this order dy by dx to dx and then dy. While changing this order from dy dx to dx and then dy, here I want to change the limits in terms of y variable. So here integrate first with respect to y and then x, limit in terms of x first. So here whenever the inner limit in terms of x variable, integrate first with respect to y. So now in the upcoming integration, so here my final answer I want here function with respect to x and then dy. So here I want to convert this inner limit in terms of y variable. So here in terms of y variable, how to change is the following. So here now just observe one thing. First I will draw the region. So with the help of this closed interval. Now here the limits of the second integral x to root x. So here that must be the value of y. That is not again the value of x. So here I am taking x which is less than or equal to y which is less than or equal to root x. Now in the same way, if this is the value of y, that must be the value of x. So here 0 is less than or equal to x which is less than or equal to 1. Now so here 0 is less than or equal to x. So here at the left end of this closed interval 0 to 1, so here x equal to 0, and the right end of this closed interval 1 times x equal to 1. Now in the same way, the left end of this closed interval x to root x, so here y equal to x and here y equal to root x. So here y equal to root x, so here this is x equal to 0, x equal to 1, here y equal to x line, y equal to root x. Here I will write this as here y square equal to x. Let's say here I am taking squaring on both sides, here taking squaring on both sides. So here y square with square and square root get cancelled, this becomes x. So here now here I want to draw the region with the help of this here interval. Now here x equal to 0, x equal to 0 means complete y axis. So here this is x axis. So here this is y axis. Here this is my origin. Now here x equal to 0 means complete y axis, and x equal to 1. Here I will take somewhere x equal to 1. So here this is the line, here x equal to 1 with coordinate 1, 0. Here I will denote this as a. Now so here x equal to 0 complete. So here this is x equal to 0 and this is x equal to 1. Now y equal to x, line passing through origin. So here I am taking this line y equal to x, and here y equal to root x. So here x equal to, here y equal to root x, x equal to y square. Just take x equal to y square means x equal to y square means here let's say here I am drawing this region. So here this is the parabola which is symmetric to x axis. Let's say x equal to y square. Here I am taking x equal to y square. Now so here, so this is my line. This is my line. So here this is the x equal to, so here x equal to y square parabola, and this is my line, and my line y equal to x and x equal to 1, and this parabola intersect at, let's say, this point. So here this is my region. Now so this is my line y x equal to 1. So they intersect at this point. Here x equal to y square and here y equal to x. Here I want to find the point of intersection at this point. Let's say this is OA and B. I want to find this coordinate of this point. So here, so this is the parabola. So of course now I want to find the coordinates. Here let's say this is the B. I want to find this coordinate. Now how to find? So here x equal to y square and y equal to x. So here I will take y square equal to x square. So here x equal to, the value of y square is x square. So here x square minus x equal to 0. I will take x common. X minus 1 equal to 0. X equal to 0 and x equal to 1. X equal to 0 and x equal to 1. When x equal to 0, when x equal to 0, y equal to 0. When x equal to 0, this implies y equal to 0. We will get the coordinate 0, 0. When x equal to 1, this implies y equal to 1. When x equal to 1,
you will get y equal to 1. This you will get the coordinate 1 comma 1. Therefore, the coordinates of these points are 1 comma 1 and the coordinates of this point are 0 comma 0 and the coordinates at this points are 1 comma 0. This is not necessary. So just observe one thing. The value of x belongs to 0 is less than or equal to x, which is less than or equal to 1. So here x takes the complete value from here to here 0 to 1, but here y takes value here. The value of y here, x is less than or equal to y, this is less than or equal to root x. So here this is x equal to y. So here the value of y which is greater than or equal to x. So here from here and which is less than or equal to this here root x. The value of y here which is less than or equal to root x means which is less than or equal to this here. So this is my region. So therefore the region of my integration is this one. So here OB. So here this is the region of my integration. Now I want to cover this region with the help of vertical and horizontal strip method. So how to use is the following. Now just observe one thing. Here I want to cover this region with the help of vertical and horizontal strip method. Here in the question. So in the question, first integrate with respect to dy and then dx. So here and these are the limits. So here first integrate with respect to dy. So here I am using the vertical strip which is parallel to x-axis. Which is parallel to y-axis. Let's say this is my strip CD which is parallel to y-axis. So here according to this order, first integrate with respect to dy and then dx. According to this order, I am drawing the vertical strip CD which is parallel to y-axis. Start on this line y equal to x and terminate on this curve, that is terminate on this parabola y equal to root x, or we can say x equal to y square. So here I want to find the value of y. So here the value of y equal to x to the value of y equal to root x. So here we are in the first quadrant. Now here I will write the limits of x. So here these are the point of intersection. Just now here I am finding. Now here limits of x and limits of y. So here limit of x and limit of y. So here limits of x. Here limits of x and limits of y. So here my strip move from this point to this point. So here this is the height along the x-axis 0 to 1. So here x equal to 0 to x equal to 1 and y equal to here height along the y-axis. So here y equal to x2. So here y, the value of y at this point, y equal to x to y equal to. So here the value of y at this point. So here x equal to y square, y equal to root x. So this is the limit corresponding to this order dy dx which is given in the question. But now I want to change this order from dy by dx to dx dy. So here in the same way I want to cover the same region but with the help of horizontal strip which is parallel to x-axis. Now my region is same. So here this is my region is same. I want to cover this region with the help of horizontal strip which is parallel to x-axis. Now here I will draw the strip. Let's say this is my strip here C and D which is parallel to x-axis. Now my strip CD which is parallel to x-axis start at this curve and terminate on this line y equal to x. So here this is the parabola x equal to y square. So here x equal to y square, and so here value of x at this point is x equal to y square, the general value, and the value of x at this line here x equal to y. Therefore limits of x start from x equal to y square to x equal to y, and limits of y. So here limits of y means, so here limits of y start from here 0 comma here height along the here my strip CD move from this point to this point. So here height is along the this. So this is the region. So here 0 to 1. So here height along the y-axis is 0 to 1. Therefore, after changing this order, so here after changing this order with respect to this horizontal strip CD which is parallel to x-axis. Here CD which is parallel to x-axis. Here start from this curve, and therefore the limits of x, here limit of x, and this is limit of y. So here limits of x, therefore limits of x are here x equal to here x equal to y square, here x equal to y square to x equal to, here x equal to y square to x equal to y, and limits of y. So here limits of y start from y equal to 0 to y equal to 1. So this is the way to change the order. Therefore after changing this order, so here first, here 0 to 1, x to root x, this is f of x comma, here y, here limit in terms of x variable dy and then dx. After changing this, so here after changing, so here I want to write the limits. So here f of x comma y. So here this is dy dx. I want to write this as dx and then dy. So here dx, I want to write the limits of x. Limits of x start from y square to y, and here limits of y. So limits of y start from 0 to 1. So this is dx dy. So here in the starting this is dy dx. Here I am changing the order dy by dx to dx dy. Here dy dx with respect to this limit and dx dy with respect to this limit. This is the way to change the order of integration from dy by dx to dx dy. Now in the same way I will solve this example again. So in example number 4 given, so here example number 4, 0 to infinity, here x to infinity and f of x comma y, here with respect to this is dx and then dy. So here this is the way, this is the given question. So example number 4. But you can observe one thing here, inner limit in terms of x variable, that must be first integrate with respect to dy and then dx. But they have in the question they are only given first integrate with respect to dx and dy. So here I am correct form of this integration. Here the correct form of this integration is 0 to infinity x to infinity f of x comma y. This is dy and this is dx. This is the correct form of my integration. So which is given. Now I want to change the order with respect to this correct form, not with this. So here in the question this is given 0 to infinity x to infinity f of x comma y dx dy. So here this is not the correct form of my integration. I want to write this integration into the correct form. So here this is the correct form of my integration. After writing this correct form of my integration, I want to change this order dy by dx to again dx dy, which is given in the question, but here limits are wrong. Here integration with respect to y. Here integration, if we are integrating with respect to x first, here limit must be in terms of y. So but here limit in terms of x. So here this is not the correct, but this is the correct form. After writing this correct form of integration, I want to change. So after correct form of integration is dy by dx when limit in terms of x variable. Again I want to change this order from dy by dx to dx dy with respect to the, here with respect to y variable limit. So here how to change is the following. Now how to change this? So here I am writing my first step. This is the correct form of my integration is this one. So here I am start writing with this. Here this is the correct form of my integration. So correct form of integration is here 0 to infinity x to infinity f of x comma y dy dx, because inner limit in terms of x variable. Now here I will draw the reason with the help of this limit. So here x to infinity, so here that must be the value of y, that is again not the value of x. So here y belongs to this interval. So here x is less than or equal to y, this is less than or equal to infinity, and here if this is the value of y, so here the first must be the value of x. So here I will draw here x is less than or equal to y, this is less than or equal to infinity. If this is the value of y, that must be the value of x. So here 0 is less than or equal to x, which is less than or equal to infinity. So here x belongs to the closed interval 0 to infinity. That means x takes all the value from closed interval 0 to infinity. So of course infinity is the not number here, but so we can write. So here you can take less, or here I am just closing. Here I am taking no issue. That is not, infinity is never belongs to this number never belongs to this closed interval. So here x is less than or equal to y, which is less than or equal to infinity. So here at the left end, so here x equal to 0, and here x rise up to, here x rise up to infinity. X is not equal to infinity, x tends to infinity. Here I am writing x extend up to infinity in the positive direction of x axis, and here x equal to y, and here y raise up to infinity. So here I am drawing this region with the help of this. So here this is my x axis and this is my y axis. This is my origin. Now with coordinate 0, 0. Now here x equal to 0. X equal to 0 means, so here complete y axis. So here along the y axis the value of x is 0. Here let's say this is the 1 curve and x tends to infinity. So here this time in this direction x tends to infinity and x equal to y, here y equal to x. So here this is the line y equal to, here x equal to y means y equal to x. This is the line passing through origin. So here that extend up to infinity in this direction. So here y equal to x line and y tends to infinity. So here in this direction here y tends to infinity and in this direction x tends to infinity. But here just observe one thing, your x belongs to this region. So here all the x belongs to this region. 0 is less than or equal to x is less than or equal to infinity. But here y belongs to this. So here x is less than or equal to y. So here x is less, here this is x equal to y. So this is x equal to y. So here value of y which is greater than or equal to x. So here this is y equal to x. The value of y which is greater than or equal to, here the y is greater than or equal to x means here this is the region. So here this is the region. So here above the line and extend up to infinity but less than or equal to infinity. So here the region of my integration is this one, bounded by y axis and the line y equal to x, and here in this region extend up to infinity. So they don't have bound on in this direction. So here in this direction, but here my region of my integration is bounded by this line y equal to x and the y axis and that extend up to infinity. Now here this is my region of integration. Now I want to cover this region with the help of vertical and horizontal strip. So here, but in the question the correct form of my order is dy dx, because limit in terms of x variable. So here that must be here I want to cover this whole region with the help of, let's say this is my region. Let's say this is my region. Here I want to cover this whole region with the help of vertical and horizontal strip method. So here first I will draw the vertical strip. Let's say this is my vertical strip. Here first integrate with respect to dy. So here, and my vertical strip, let's say this is C and D, start at the line y equal to x and extend up to infinity to cover this whole region. And therefore the point of intersection, here only point of intersection is at origin, so there is no point of intersection at this point. Now just tell me, so I want to cover this whole region, so which is bounded by my y axis and this line y equal to x. Y axis means x equal to 0 and this line x equal to y, or you can say y equal to x. Now tell me the limits of x and limits of y corresponding to this limit. So here the value of x, the limits of x and limits of y. So here I will write limit of x, limit here of y. So here limits of x. So here x equal to limits of x. So here this is the way, here x equal to x equal to 0 to x equal to infinity. So yes. Here this is the limit. Here at this point 0, 0 and the value of x equal to y. So here but this extend up to infinity and the limits of y start from y equal to x up to infinity. Y equal to x up to infinity. Therefore limits of x corresponding to this, here x equal to 0 to x equal to 0 up to here height along the y axis. So here this line, so this value, this line at this point, let's say this is, let's say for the sake of understanding, let's say this is 1 comma, let's say this is 1 comma 1. So here height along the x axis is 1, height along the y axis is 1. But here limits x tends to infinity. So here there is a no point of intersection. So here this line is extend up to infinity. So here limits of x start from 0 and x tends to infinity. So here x equal to 0 to x equal to infinity. And now tell me the limits of y. Limits of y start at this point and one terminal of this strip CD start at this line y equal to x, and the other terminal don't have any means bound. So therefore that strip CD extend up to infinity to cover the whole region. So here limits of y, here y equal to x to y equal to infinity. So here these are the limits corresponding to this order dy by dx. But now I want to cover the same region with the help of horizontal strip which is parallel to x-axis. So here I want to cover the same region with the help of, so here horizontal strip which is parallel to x-axis. Let's say this is my strip CD. So here this is y equal to x line. So here this is y-axis. So here and this is x-axis. So this is my origin 0, 0. Now tell me. So here I want to cover the same region. So here which is bounded by y-axis and line extend up to infinity with the help of horizontal strip CD which is parallel to x-axis. Now here my strip CD start at y-axis x equal to 0 and terminate on this line everywhere. So here at this point x equal to y. So here the limits of x and limits of y after changing. So here after changing order limits of x. So here limit of x, limit of y, limits of x and limits of x are x equal to 0. So here start at y-axis x equal to 0 to x equal to, so here y. So x, the value of x at each and every point. So here y equal to x equal to y, and limits of y. Here y equal to, here 0 to up to infinity. Y equal to 0 to y equal to infinity. Therefore after changing this order, therefore the correct form. So here 0 to infinity, x to infinity, this is f of x comma y. So here with respect to this is dy and then dx. Correct form after changing this. So here after changing this which is equal to. So here f of x comma y, here I want to change this order by dy dx to dx and then dy. So dx dy. So here I am integrating first with respect to x. Write the limits of x equal to 0 to y and limits of y equal to 0 to infinity. So this is the change of order from dy dx to dx and dy. So in the starting dy dx correct form after changing dx dy with respect to y limit. So with respect to x limit in y variable. These are the so integration with respect to y in y limit with respect to here in y in x variable. So here these are the limits of y in x variable. That's why here we integrate first with respect to y and then dx. Now I am changing from the dy dx to dx dy. So this is first integrate with respect to x and then y. While integrating first with respect to x, write the limits of x in terms of y variable and then write the limits of y which is constant, y equal to 0 to infinity. This is the way to change the order from dy dx to the correct form of dy dx to the after change this order dx dy. In the same way I will solve example number 3. Now here example 3 says, so here first I will write the example 3. So here given information example 3 integration from 0 to a here with limit and x to a. So here f of x comma y. So here this is dy and dx. So here inner limit of the second integration in terms of x variable. So integrate first with respect to y and then x. But now I want to change the order of integration from dy dx to dx dy. So for that purpose I want to change the limit in terms of y variable. So here first I will draw the region with the help of this limit. So here 0 to a. So here in the limits are 0 to a and the second integration x to a, that must be the value of y. So here x is less than equal to y, which is less than or equal to a, and if this is the value of y, that must be the value of x. So therefore 0 is less than or equal to x, which is less than or equal to a. Now here this is the closed interval 0 to a, and at the left end of this closed interval here x equal to 0 and the right end of this closed interval x equal to a. So therefore once at the here x takes all the value from 0 to a, therefore at the left end of this closed interval x equal to 0 and the right end of this closed interval x equal to a. So this is x equal to 0 and x equal to a. Now in the same way here y equal to x, that is at the left end, and at the right end y equal to a. So here x equal to 0, x equal to a, y equal to x and y equal to a. Just draw the line. Let's say this is your xy plane. Now here this is my x axis, so this is my y axis. So here this is x axis, y axis, and this is my origin, with coordinate 0, 0. Now here x equal to 0 means complete y axis. So here x equal to 0 means complete y axis, and x equal to a, let's say this is the a, so here let's say this is my coordinate a, and x equal to a, this is my complete line x equal to a, let's say this is my x equal to a line, and here y equal to a, let's say here I am taking y equal to a, this is my y equal to a line. So here x equal to a line and y equal to a line intersect at this point, let's say this is the point P with coordinate a comma a. So here this is x equal to a line, this is y equal to a line, and this is the point P where x equal to a and y equal to a intersect. Now here y equal to x, so here this is the line, here y equal to x. Now we have to decide the region. Here just observe one thing, 0, x takes all the value from 0 to a. So here x takes all the value from 0 to a, x takes all the value from x equal to 0, so along the y axis to x equal to a line, up to x equal to a line. Now but y, here this is my y equal to x line, but y is greater than or equal to x, so this is y equal to x, and y takes all the value which is greater than or equal to here x. So here x is less than or equal to y means y is greater than or equal to x, and reach up to the less than or equal to a means all this point. So my region of my integration is this triangle. Now this is the region of my integration. Now I want to here, so this is the region of my integration. So here let's say this is the a. Here for the to find the point of intersection, here I am writing here just now I draw the line x equal to a. So this is the point P where y equal to x, y equal to x, and y equal to a and x equal to a line intersect. So this is the point P. So here this is origin. Here I am taking the point of here I am taking the point Q with point of intersection 0, a. So here a, x coordinate is 0 on y axis, here y coordinate is 0 on x axis. Now here this is my region of integration. So this is complete triangle. So here triangle O P Q is the region of my integration. Here in the given question, first integrate with respect to dy and then dx. So must be they are using the vertical strip. So here must be they are using the vertical strip AB which is parallel to y axis. Let's say this is the vertical strip CD which is parallel to y axis. So here this strip CD start on the line y equal to x and terminate on the line y equal to a. So here just observe this strip CD, here the region of my integration, the region of my integration is the triangle OPA, and my strip CD which is parallel to y axis, here which is parallel to y axis, start from y equal to x and terminate on the line y equal to a. So here limits of x, how to write limits of x and limit of y, so corresponding to this strip CD. So here limits of x start from here, height along the x axis. So here 0 to a, limits of x start from x equal to 0 to x equal to a. So here x equal to 0 to x equal to a. So here on the y axis x equal to 0, and here up to this point x equal to a. So here actually I want to cover this region, so I want to cover this triangle with the help of this strip. So here first I will move this strip here to cover this region. I want to complete the whole region. So here my along the x axis, so here my strip start from this point to terminate at this point. So here my movement start from this point and terminate my movement at this point here, and height y start from y equal to x and terminate the height of my strip at y equal to a. Therefore here this is the height along the y axis, limit y, here limit x equal to 0 to x equal to a, and y equal to, so here y equal to x to y equal to a. These are the limits of this region corresponding to this integration. First integration with respect to dy and then dx. So here these are the limit. But now I want to cover the same region with the help of horizontal strip. That's why here I want to cover the same region with the help of horizontal strip. So here I am using the vertical strip which is parallel to y axis. So that's why first integrate with respect to dy and then dx. Now I want to draw the horizontal strip which is parallel to x axis. Here I want to change that dy dx to dx dy. So here I want to here cover the same region. So here this is the region. Let's say P A comma A. So here this is y equal to A line. So here this is the y axis and this is x axis and this is origin 0 comma 0. Now tell me, here I want to cover this whole region with the help of horizontal strip CD, horizontal strip CD, which is parallel to x axis. So this is the line y equal to x or x equal to y. Now this is the line y equal to x. Now tell me, here my strip CD start on y axis here and my strip CD start on y axis and terminate on this line here y equal to x. So here the value of x on y axis is x equal to 0 and the value of x, the general value of x on this line x equal to y. Therefore limits of x, so here limits of x and limit of y. So here limits of x are x equal to 0 to x equal to y. So here x equal to 0 to x equal to y and limits of y. Here limits height along the y axis 0 to a. So here these are the coordinate, here 0 comma a. So here y equal to 0 to y equal to a. Therefore after changing the order, so here first I will write limit here. Therefore after changing the order, here 0 to a x to a f of x comma y. So here inner limit in terms of x, first integrate with respect to dy and then dx. Now I want to change the order with respect to this limit. Therefore here this is f of x comma y. So here I want to change from dy dx to dx dy. So this is dx and dy. So here integrate first with respect to x and then y. If you are integrating first with respect to x, write the limits of x. So here x equal to 0 to x equal to y and here limits of y. After that y equal to 0 to y equal to a. So this is the way to change the order from dy dx to dx dy and these are the limits with respect to x and these are the limits with respect to y. So here this is the way to change the order from dy dx to dx dy. In the same way I will solve example number 2. So here how to solve. So this is the example number 3. Now here first, now I will write the example number 2. So here this is given. First write the given. So here in example number 2. So here limits are 0 to 1. Here 0 to y. This is f of x comma y. This is dx and then dy. So here this is the correct form of correct order of your integration. Second limits in terms of y variable, first integrate with respect to x and then y. So here now I want to draw the result with the help of this limit. So here limits of the second integration from 0 to y, so that must be the value of x. Therefore 0 is less than or equal to x, which is less than or equal to y. If this is the value of x, that must be the value of y. So here 0 is less than or equal to y, which is less than or equal to x. Now here in this closed interval, so here this is 1. Now in this closed interval 0 to 1, at the left end y must be 0 and at the right end y must be 1. So here y equal to 0, y equal to 1 line. Now here come to this closed interval 0 to x, x must be 0 and at the right end x equal to y, or we can say y equal to x. Now here now draw the region. Here this is my x axis, this is my y axis, this is my origin with 0 comma 0 coordinate. Now here y equal to 0, here y equal to 0 means complete x axis and y equal to 1. Let's say here I am taking one line which is parallel to x axis. Here let's say this is my line y equal to 1. Now here x equal to 0 means here y equal to 0. Here let's say this is here y equal to 0 and let's say this is x equal to 0 is my y axis. So here y equal to 0, so here x equal to 0, so here x equal to 0. Now y equal to x, the line passing through origin. So here, so this is the point of intersection where y equal to 1 and y equal to x intersect. So here y equal to 1 and y equal to x, therefore x equal to 1. So the point of intersection is here P with 1 comma 1 coordinates 1 comma 1. Now here this is the point of intersection of y axis and the line. y equal to 1. Therefore, so here I will take this as q. So here x coordinate is 0 and y coordinate is 1, and this is the one point of intersection in 0, 0. Now just identify the region. So here 0 is less than or equal to y, which is less than or equal to 1. So here the the height of y from 0 to 1. So here this is the complete region of here corresponding to this interval, and corresponding to this interval. So here 0 is less than or equal to x, is less than or equal to y. So here the value of x which is greater than or equal to 0 and less than or equal to y. So here this is the line y equal to x. So here this is the line y equal to x, and where is the y equal to this is y equal to 1. So here y equal to x. Yes, tell me. So here so the value of x which is 0 is less than or equal to x. So here the value of x is greater than or equal to 0 and less than or equal to y. So here the region of my integration is this triangle. So here the value of x which is less than or equal to y. So this is y, x equal to y. The value of x is, so this is less than or equal to x, and the value of x is greater than or equal to 0 means this is the x is greater than x equal to 0 and x is greater than or equal to 0 means this is the line. So here this is the region. So here I want to cover this region with the help of, so here in the starting they have given integrate first with respect to dx and then dy. So here if they are integrating first with respect to dx means of course they are using the horizontal strip which is parallel to x axis. Now here tell me, so this is the line y equal to x. Now how to find? So here this is the line, this is the strip CD which is parallel to x axis. Now I want to find the limits of x and limits of y with respect to this limit which is given in the question. So here now limits of x. So limit of x, my region of my integration is OPQ. Now after that find the limits of x and limit here limit of y. So limits of x. So here along the positive direction of x axis, x equal to 0 to x equal to 1. So here x equal to 0 to x equal to 1. So therefore x equal to 0 to x equal to 1, and limits of y. So here y start from 0 to 1. So here along the positive direction of y axis, along the y axis. So here y equal to 0 to 1. So here y equal to 0 to, so here x equal to 0 to x equal to y. So here x equal to 0 and x equal to y. Here y equal to x. My strip CD start on y axis and terminate on y equal to x line. So here the value of x on y axis is x equal to 0 and the value of x on this line x equal to y. So here x equal to 0 to x equal to y, and the value of y start from 0 to 1. So here y equal to 0 to y equal to 1. So here this is the limit which is given in the question. Now I want to cover the same region with the help of vertical strip, because I want to change order from dx dy to dy dx. Here in the question this is given dx dy, but I want to change dx dy to dy dx. So for that purpose I want to integrate first with respect to y and then x. So here I will cover the same region with the help of vertical strip in place of horizontal. So let's say this is the region. So here let's say this is the region O with coordinate 0, 0. This is the P with coordinate 1, 1. This is Q with coordinate 0, 1. Now here this is my line y equal to x. This is my line y equal to 1, and this is x equal to 0. Now I want to cover this same region with the help of vertical strip method. So here let's say this is my vertical strip. Let's say this is the CD is the vertical strip. My vertical strip CD start at the line y equal to x and terminate on the line y equal to 1. So here and my limits of x. So x equal to 0 to x equal to 1, and limits of y equal to x to y equal to 1. Therefore here my region is same. Here limit of x and limit of y. So here limit of x are x equal to 0 to x equal to 1, x equal to 0 to x equal to 1, and limits of y equal to x to y equal to, so here y equal to x to y equal to, so here this is 1. Therefore after changing the order, so from here this is the horizontal strip integration with respect to dx dy, this is the vertical strip integrate first with respect to y and then x. Therefore after changing the order from dx dy to dy dx. So here from dx dy, so here 0 to 1, 0 to y, this is f of x comma y, this is dx and dy which is given in the question. Now I want to change the order. So here after changing the order, here I want to change this order dy dx. So this is f of x comma y, this is dy and then dx. So here I am integrating first with respect to y. So here put the limits of y. So here y equal to x, here y equal to x to y equal to 1, and after that integrate first with respect to x. Then put the limits of x, x equal to 0 to x equal to 1. So this is the way to change the order from dx dy to dy dx. So dx dy with this limit and dy dx with this limit. This is the way to change the order from dx dy to dy dx. So in the same way I want to solve the example number 2. So example number 1. Now I want to solve the example number 1 to change the how to change the order. Now here in example number 1 which is given, so here integration from 0 to 1 from 0 to x, f of x comma y dx dy. Just observe one thing. So here the inner limit in terms of x variable, that must be, so if inner limit in terms of x variable, so must be integrated first with respect to y and then dx. So this is not correct order. So this is correct, order is not correct. Here order is not correct. So here to make the order correct, so here 0 to 1, 0 to x, f of x comma y, this is dy and then dx. So this is the correct order. So here order is correct. Now I want to change the order with respect to this correct order. So here this is the correct order of your integration. If your limit, inner limit in terms of x variable, so dy dx is the correct order of my integration. Now I want to change the order of integration from dy dx to dx dy with respect to this limit. Now here just observe one thing, inner limit in terms of x variable, so here that must be the value of y. Therefore 0 which is less than or equal to y, which is less than or equal to x. Now here come to this, if this is the value of y, that must be the value of x, which is less than or equal to 1. Now here closed interval, in x take all the value from closed interval 0 to 1. Therefore x 1 times at the left end x equal to 0 and at the right end x equal to 1. Here at the left end y equal to 0 and at the right end, so here y equal to x. So these are the curve, x equal to 0, x equal to 1, y equal to 0, y equal to x. Now here I will draw the region, and here let's say this is my x axis, let's say this is my y axis, and this is my origin with 0, 0 point of intersection. Now x equal to 0 means x equal to 0 means complete y axis. So let's say this is x equal to 0 and here y equal to 0 means let's say here I am taking y equal to 0 is along the x axis. Now x equal to 1, so let's say here I am taking somewhere x equal to 1. So this is the line. So here let's say this is x equal to 1 and y equal to x. Let's say here I am taking the line passing through origin, which is y equal to x. Now just observe one thing, the x value of x is in between close interval 0 to 1. So here let's say this is the coordinate 1, 0. So here let's say I will take this is a, let's say this is p, o p, o a p. So this is the region of my integration. So here 0 is less than or equal to x, this is less than or equal to 1. So along the x axis, and along the y axis 0 is less than or equal to y, means the value of y is greater than or equal to 0 and which is less than or equal to x. So here y equal to x, this is less than or equal to y. So here y, here 0 is less than or equal to y, which is less than or equal to x. So here this is the region of my integration, is this triangle OAP. Now so here I will write this y equal to x line. So here y equal to x, and the point of intersection of this line x equal to 1 and the y equal to x is 1, 1. You can find here y equal to x and x equal to 1. So here y equal to 1. So this is the point of intersection, and at 0, 0, 0 is the point of intersection. Now I want to cover this region, but in the question they have given the correct order dy dx. So here first integrate with respect to dy. Here with respect to this strip is corresponding to the correct order of your integration. So this is dy dx. Now here I am taking the strip, let's say CD, which is parallel to here, which is parallel to y axis. Now here this is my line x equal to 1. So here this is my line x equal to 1. Now my strip CD start on x axis and terminate on the line y equal to x. So here and along the here height along the x axis is 0 to 1. Therefore here first I will write the limits of x and limits of y. So here my region. So here my region is triangle OAP. So this is the region of my integration, and in this region limit of x and limit of y. So here limits of x are limits of x from 0 to 1. So here limits of x start from x equal to 0 to x equal to 1, and limits of y. My strip CD start on x axis and terminate on this line. So on x axis y equal to 0, y equal to 0 to y equal to x. So these are the limit corresponding to this order dy dx, which is the correct form of order with respect to this limit. So these are the limit. Now I want to change. I want to cover this same region with the help of horizontal strip which is parallel to x axis. So here this is the region. Region is same. I want to cover this same region with the help of horizontal strip which is parallel to x axis. So here this is y equal to x, and this is the horizontal strip CD which is parallel to x axis. Now this is my line x equal to 1, and this is my line y equal to x, and this is my x axis. If x axis means here y equal to 0. Now here I want to find the limits of this region. Here I want to change the order from dy dx to dx dy, so that I want to find the limits. So here I want to find the limits with respect to dx dy. Now here tell me my strip CD start on y equal to x line, and my strip CD terminate on this line x equal to 1. So here, so at this point along this line y equal to x, the value of x equal to y, and at this point along this line the value of x equal to 1. Therefore limits of x here, limit of x, and limit here, limit of y. Now tell me limits of x start from x equal to here x equal to y to x equal to 1. So here x equal to a, my strip CD start at this point and terminate at this point. So here height along the x axis x equal to y to x equal to 1, and height along the y axis here y equal to 0 to y equal to 1. So here y equal to 0 to y equal to 1. So here these are the limit with respect to horizontal strip CD which is parallel to x axis. Therefore after changing this order, double integration, so here 0 to 1, 0 to x, f of x comma y, this is dy dx correct form. Here I want to change this correct form dy dx to dx dy. So here limits f of x comma y, here I want to change from dy dx to again dx and dy. Here I want to integrate first with respect to x. So write the limits of x equal to y to x equal to 1, and after that limits of y equal to 0 to y equal to 1. So this is the correct way, this is the correct, so this is the change. Here this is the correct form, but in the question limits in terms of x, but they are here writing dx dy. So correct form is dy dx. So after writing this correct form, here I am changing dy dx to dx dy with respect to this limit. So this is dy dx with respect to this limit. This is the way to change the order from dy dx to dx dy and dx dy to dy dx. So here now I will explain one short trick. So here how to decide. So for example some normal question come. So here whenever how to check the correct order. So for example let's say this is 0 to a, and let's say this is 0 to x. So here double integration 0 to x and any function f of x comma y. So whenever the inner limit in terms of x variable, at that time first integrate with respect to dy and then dx. So here this is the correct order. So here whenever inner limit in terms of x variable, first integrate with respect to y and then x. So here second thing 0, let's say 0 to a, let's say this is 0 to y, f of x comma y function. Here whenever your inner limit in terms of y variable, at that time first integrate with respect to dx and then dy. So this is the correct order. So here keep in mind, whenever inner limit in terms of x variable, integrate first with respect to y and then x, and whenever your inner limit in terms of y variable, the correct form integrate first with respect to y and then integrate first with respect to x and then y. So this is the way to change the order. So this is the way to solve this integration, double integration. So here maybe in the any exam they will ask change the order of integration and evaluate the integral. First of all you have to identify the region, and so whatever the given region, according to this order, correct order, write the limits of x and limits of y. After that change the limits of x and y and change the order. So here if you have dy dx, so then change from dy dx to dx and then dy. If you have dx dy, change from, if you have in the correct form, if you have dy dx, change from dy dx to dx dy, and in the correct form if you have dx dy, change from dx dy to this is dy dx. So this is the way to change the order of integration from dy dx to dx dy and vice versa. So thank you.